Hello, ladies and gentlemen. Welcome back to Math 30-2, Chapter 3, Section 2, Probability and Odds. So, I've talked about odds and probability. Let's do some more questions, see if I can clarify what's what. So, a computer randomly selects the university student's name from the university database to award a $100 gift certificate for the bookstore. The odds against the selected student being male are 57 to 43. Determine the probability that the randomly selected university students will be male. Now, a few things to point out here. Selects university. Now, the odds against being male, 57 to 43. All right? So this is not male versus male. 57 to 43. That's odds. We're going to probability. Now, probability. Male. Is number of males over total. So, how many males do we have? 43. What's our total number? Well, the total is 57 plus 43, which is 100. So that is 43% of 0.43. Okay? So the probability the randomly selected university students will be male, 43%, 43 over 100, or 0.43. And yes, I expect you to recognize all three answers. Okay? So far, so good-ish? Well, I hope so. Suppose that the odds in favor of an event are 5 to 3. Okay? What is the probability that the event will happen greater or less than 50%? Well, here, suppose the odds in favor of an event are 5 to 3. What we want versus don't want. That's 5, 8, so 3. Let's do more. Now this could be win, lose, I don't know. So probability of what we want is the number that we want over total. So that's going to be 5 over 5 plus 3. That's 5 over 8. Grab Mr. Calculator. 0.625. Multiply that by 100. 62.5%. Okay? Okay. So far, so good? So odds to probability, probability to odds. That's what you need to be able to do. I'm going. So a hockey game has ended in a tie after a 5-minute overtime period. So the winner will be decided by a shootout. The coach must decide whether Ellen or Brittany should go first in the shootout. Ellen has a 61.5% probability based on her last 13 attempts, while Brittany has odds 10 to 7 for scoring a goal. Who should go first? Now, instinctively, most of us do probability percentages fairly well. So Ellen is 61.5%. Let's do Brittany. Brittany odds, this is goal, not goal. So the probability of getting goal is 10. 10 plus 7 total. So it should be the number of goals divided by total. So it's going to be 10. 10 plus 7, which is 10 over 17. And so I'm going to do a 10. Well, I can probably figure it out. It's so easy. Makey. 10 divided by 17 is 58.8%. Okay. So, who should go first? Brittany or Ellen? Well, I think it should be Ellen. She has a better percentage. Okay, not much, but I'm going to slightly better. All right, so far so good? Good. Now, Jose is also on the team. She has scored twice in 3 shootout attempts. Should the coach put her first? Explain. Twice in 3 shootout attempts. So, should the coach put her in first? Now, probability of a goal here is number of goals total. So for Jose, she has 2 out of 3, 0.667, which is 66.7%. So, should we put her in? Yes or no? Now, most people instinctively say yes, because she has the best percentage. But think about it for a moment. Can you come up with a counter argument? Yes, she's done it 3 times. What if she just got lucky? This is like flipping the coin and getting heads 3 out of 4. 3 out of 4 times. Are you naturally good at 2 out of 3 times? Are you naturally good at getting heads? Or are you just lucky? So you can make a very good argument here that God help me. Sorry. That the number of events here, or as we said in last lesson, the event is not big enough. She only did it 3 times. Maybe we should wait till she does it 10 times and then look at her results, or 5 or 6 times. Maybe she just got lucky, and she got 2 or 3, or maybe she got unlucky and she should have got all 3. We can make a very good argument that she should do this a few more times. Or we can say no, not enough data for results. Yes. So we need more data, or we can make that argument. Once again, this is one of those questions where there is no correct answer. You have to justify your answer. Okay? All right, last question. So, a group of grade 12 students are playing a game, charity carnival. Try this again. A group of grade 12 students are holding a charity carnival to support a local animal shelter. The students have created a dice game they call BIM, and a card game they call Zap. The odds against winning BIM are 5 to 2, and the odds against winning Zap are 7 to 3. Which game should Madison play? No. Against and game. Okay, now the question is, which game should Madison play? Now, assuming Madison wants to win, because it's being charity, someone will make the argument that, no, she wants to lose money. Anyway. Let's look at them. Okay? This is against. Against are 5 to 2. Odds 4 are 5. The probability of winning is 2 out of 2 plus 5, 2 out of 7, which is 28.5%. Okay? Now, I'm going to pause the recording. I want you guys to tell me the odds against and the odds for Zim, and what's the percent chance of winning. Okay, so you guys do that. Okay, so the odds, playing Zach, the odds against are 7-3, which makes the odds 4, 3-7. 3 wins and 7 losses. So probability of winning is 3 out of number of wins, 3 over total, 3 plus 7, 10. Which becomes 3/10, which is 30%. So if Madison wants to play, what game should she win? Oh, this wants to win, I'm sorry. What game should she play? Zach. Notice the odds of her winning 30% versus 28.5, but money's money. So, if you want to win, Zach is slightly better. Or, since it's less than 50%, it sucks. But it sucks less than 50. Right. Now, that is it for me. If you've got any questions, shoot me an email or see me in class. Otherwise, good luck, and I'll see you in class.